Back in 2014, I made a mailbox notification system that used an Arduino, in this case an Arduino Pro Mini, and an XP radio, actually a set of them, one in the mailbox and one inside the house. And the setup worked fine, but I've wanted to update it for a while, and that's what I have here, the updated version. And I'm making this video to talk about a few things that I encountered along the way in getting this new setup working. This video will just be me talking and maybe some clips of the system in action, so it may be boring. It'll be pretty exciting. So real quick, the way the old system worked, the mailbox we use is a locking style that has two doors, one for delivery and one for retrieval. On each door I put a read switch. When the mail was delivered, the Arduino would use the XP to send delivery information to the XP in the house. And it initially just started out sending a notification, delivery notification, that turned on a light in the house to let us know that the mail was delivered. But I later added a screen that would show the date, time, and temperature and the battery level when the mail was delivered or retrieved. The Arduino would also turn on two LEDs on either side of the mailbox as notification that mail was delivered. Now, the old system wasn't without its problems. About a year or so after putting the system in place, we replaced all of our 1970s era windows. And after the new windows were in place, the reliability of the XP went down considerably. It's probably due to the UV coatings in the new windows. I ended up using a third XP as a repeater to ensure that the house side received the notification. Even then it was still iffy, and honestly I'd always been asking a lot of the XP. Our mailbox is maybe 70 feet from the house, and the signal had to get inside the house, so it's asking a lot for a tiny little radio. These aren't very powerful, and they're really meant to be either in a mesh setup or fairly close range. With the new system, I wanted to replace the inside notification, the light, with an email notification. I still wanted all the other data, the date and time and temperature and battery level as well. So I decided to use an ESP8266, which is a microcontroller with built-in Wi-Fi. It's not an Arduino. You can program it like one using the Arduino IDE if you want, and a lot of the functions like reading pin state and such work the same way, or nearly the same way. Out of the box though, you can easily connect to a wireless network and interact with the ESP8266 over your local network or the internet if you want to. Now the ESP is just a chip, and there are a ton of different breakout or development boards for it. You can get them for pennies on eBay, but I'm using the SparkFun Thing Dev. Adafruit also makes one, but I used the Thing because unlike a lot of the breakout boards, it has a UFL connector for an external antenna. I didn't think the PCB trace antenna would work very well given the distance and the fact that it would be inside of the metal mailbox. I'm using a 4400 milliamp battery that's recharged by a solar panel on top of the mailbox. I'm using an Adafruit solar charger, and the whole system as it sits here briefly peaks at about 126 milliamps when the ESP is connected to Wi-Fi and sending data. Even at that level, the battery would provide about 24 hours of use, but in order to be as ridiculous, as efficient as possible, I wanted to lower the power consumption of the system as much as possible. And the easiest way to do this is to put the ESP to sleep when it's not being used, which is most of the time. In microcontroller land, there are two, that I know of anyway, methods to make the controller sleep. That is to basically shut it off except for the systems necessary to wake it back up. The first is to use a watchdog timer, which basically shuts the microcontroller off for a period of time, wakes it up, runs a routine, check a sensor reading, for example, and then goes back to sleep. Rinse and repeat. The second is to put the microcontroller to sleep and only wake up when there is an external event, an interrupt. This is called the deep sleep, and it offers the most power savings because the controller can turn off most of its subsystems. And deep sleep is what I used with the original Arduino version of this setup, and it's what I wanted to use for this new version as well to save the most power. A watchdog timer doesn't make sense in this case because even if I set it for a ridiculously low interval, it's conceivable that the event of mail being delivered could be missed. The watchdog is useful for things like a water leak detector or a weather station, where you only need to check for an event or value every few seconds or every few minutes. In this case, I need the controller to wake up and process as soon as the mail is delivered, that is, that the delivery door is opened. But this presents two problems. When the ESP is put in a deep sleep, you can only wake it up with a watchdog timer or by fully resetting it. Unlike the Arduino, the ESP does not have external interrupts that are active and usable during deep sleep. Also, when the ESP is in deep sleep, the state of all the pins is set to low, but I need them to remain high in order to keep the notification LEDs on after delivery. I don't want to have to run the microcontroller the whole time just to keep the lights on. To get around these issues, I used, bear with me, a second microcontroller. The ATtiny85 is a baby Arduino. It has 5 usable pins, is completely self-contained. Just feed it power and it'll run, no external components necessary. And it only costs about $1. The useful thing is that the ATtiny behaves the same way as a full-sized Arduino when it's sleeping. You can put it into a deep sleep and wake it up with an external interrupt, and the pins stay in the state they were in before going to sleep. So if you set the pin high to turn an LED on, it'll stay that way when it's asleep. So how does this all work? When powered on, the ESP and the ATtiny go to sleep. The reed switches on the mailbox for the delivery and retrieval door are connected to the ATtiny. When the mail is delivered, the doors open, the ATtiny wakes up, turns on the notification LEDs via the relay, and also resets the ESP via the relay. It then goes back to sleep. I'm using a DPST relay, that's double pull single throw. So there's essentially 2 relays in this one package. And the reason I'm using it is because, one, it's easy to use to reset the ESP by grounding the reset pin momentarily, and it also allowed me to power both mailbox LEDs at their max current while only using 1 pin of the ATtiny. Otherwise I wouldn't have had enough pins to do everything. When the ESP is reset by the ATtiny, it gets the date and time from a local NTP server, reads the temperature inside the mailbox from a DS18B20 sensor, reads the battery voltage from its ADC input, and then sends all this information out in an email. The email portion can be tricky. I don't want to rely on any external services beyond my email provider, which is Gmail, but the problem here is that you can't connect directly to Gmail's SMTP server to send an email with the ESP because it doesn't support the TLS protocol. To get around this, you can use an SMTP server that doesn't require a secure connection. SMTP2Go offers a service that'll let you connect to their unsecure SMTP server, but since I have my own internal postfixed server, I used that. The ESP connects to my internal server, and if you've ever sent an email via telnet session, this is basically how it works. The ESP is sending the SMTP command, and if it doesn't get an error, it continues until the email is sent. Now, my SMTP server is not publicly exposed. It relays through Gmail. Since it's a full-blown computer, it has the capability to securely connect to Gmail's SMTP servers to send mail. Once the email is sent, the ESP goes back to sleep and waits for the process to start again. When the mail is retrieved, the ATtiny turns on the mailbox LEDs, turns on the dome light inside the mailbox, and waits for the retrieve door to be shut. It then turns the dome light off and goes back to sleep. Now, when sleeping, the entire system, microcontrollers, charger, everything, use 0.4 milliamps. When the mailbox LEDs are on, it uses 48.7 milliamps, and when active, it peaks briefly at about 128 milliamps. To be clear, I don't care about snail mail this much, but the exercise of making a system work inside a set of constraints is kind of fun. And it also informs other, perhaps more important projects down the road. For example, I have this alarm that I made using a 555 timer for our big freezer. This is to detect if the freezer door is left open for too long. The problem with this is it only works if someone's home to hear it. After doing this, I now have some insight into how I can make a system that's low power enough to run off a 9-volt battery, say, for a very long time, but also have the ability to not only sound an alarm, but also send an external notification, like an email or text message, so we know even when we're home if there's a problem with the freezer, if it's the freezer door is left open. I'll have some links down below, and I hope you enjoyed watching this. If you like it, please give it a thumbs up, and be sure and subscribe. Thanks.
Thanks for watching. Like and subscribe.